Okay, good morning. Welcome back. Hope everybody had a good weekend. Okay, so we're gonna do. This is our last meeting that doesn't include office hours, I guess. And so the plan is this is our last week of the semester, right? And so today we'll do the practice exam. We'll do a review session for the final today in the WebEx session, and then at the end of that, I'll post your final exam, which will be due in a week via email, just like the other exams. And then Thursday, I'll have office hours like I usually do after the exam is posted. And so if you have any questions on the exam or anything, because this is our last week, make sure you come Thursday because I'll be here the same time for office hours. And then I'll get your grades in sometime by the end of next week, and that'll be it. But let's finish up. So we got to do the practice exam for the final, and then we'll post or I'll post the final that you'll have a week to do. And yeah, so if you go on the Blackboard, you can go to final exam, fall 2020, and you'll see that I posted the practice exam with some solutions. And so let's go over that now. And then once we're done with this, once everyone feels good about the exam, I'll go ahead and post the final right here on this. Oops. All right, so let's just, I have the solutions here, but I think the best thing to do is just open up, well, first let's open up the PDF. All right, so your final is going to be similar to this one we're about to do. So you're going to have 5 questions, 20 points each. So you'll have one on the multiple regression where we had the different types of units or different types of products and how to interpret that. You'll have one on the multiple regression where we had the binary variables. So remember that one. Number 3 will be on the techniques we learned for forecasting, the simple exponential smoothing and moving average for that example, and then what we did for the little stock market forecasting example or assignment. And then the last 2 will be on what we did in the simulations chapter 10 material. So number 4 and number 5 will both be based on kind of example 10.2 and what we did in the simulations last week. So 3 questions from chapter 14, I think, and then 2 questions from chapter 10. All right, so let's go through these examples, and then I'll post your exam after we're done with this.
Professor,
Yes.
question.
Yeah.
Are you recording this? What is it? The study guide, like talking about it, or no?
So what's the question?
Are you recording
Oh
the
yeah,
class
yeah,
right
yeah,
now? Or?
yeah. We're recording. Yeah.
Oh, okay, cool. I'm at the DMV. Sorry.
Oh no, that's okay. Yeah. So this is recorded just like everything else. So if you miss something, if you at the DMV, you might miss something. Then I'll put it on YouTube later. All right, so you
All right,
can
thank
catch up if you have to do stuff at the DMV. Okay. Yeah. So let's go to let's open up the Word document one, and then we'll solve the problems. So here's the practice exam, fall 2020, the Word document. Okay, so here we go. Let's see. All right, so number one will be on the cost regression 2 spreadsheet we did in class like a month ago or a little bit more. And so using data analysis, we estimated a multiple regression with total cost as the dependent variable and units A, units B, and units C as the 3 independent variables. So the separate products cost a different amount, and we're trying to see how that relates to total cost individually. So what's our multiple regression equation using the estimated coefficients? All right, so all you got to do is go down to the summary output and use these coefficients to write out your equation like we did in class. So these are how total cost is affected by intercept and the 3 different units. All right, so total cost equals intercept, which is 8,740 and 4 cents. All right, then plus the coefficient for units A, which is 7.90. Right, times units A. All right, and then you got the coefficient for units B, which is 9.56. Okay, and then finally you got the coefficient for unit C, which is 7.31. All right, so there's your equation with using the coefficients. So make sure you do that. You're estimating how total cost is a linear function of the intercept and then the coefficients and the different types of units. Okay, so that's A. Okay, B, you got to interpret the R square and then the coefficients. Okay, so we've done this, but okay, so the R square, it said R square adjusted. The R square. So the R square is 0.95. Okay, and remember that is the percent of the explained variation in the dependent variable, which is total cost for this example. Okay, so we explained approximately 95% of the variation in total cost, right? All right, so approximately 95% of the variation in total cost is explained by this regression. All right, then let's interpret the 3 coefficients. Okay, so the coefficients are here, but we got the coefficients to interpret for units A, units B, and units C, right? That individual effect, how they differently affect total cost based on this analysis. Okay, so the coefficient for units A is 7.90. The coefficient for units B is 9.56. And the coefficient for unit C is 7.31. All right, so remember each of these is just the individual effect on total cost if this variable changes by 1 unit. So 1 unit is just producing one more. So these are the average costs of producing 1 unit of each of the types. Okay, so just go with that. All right, so producing 1 unit of product A, it has a total cost or costs about $7.90, just the exact coefficient. Okay, this is the effect on the y variable, which is total cost. And do the same for the other ones. All right, this one costs a little bit more. So the cost of 1 unit B is about $9.56. All right, and this one's the cheapest, producing an average of unit A or unit C costs about $7.31 to produce 1 unit. And let's just add like the descriptor here that this is the average cost and holding everything else constant. All right, there you go. So that's the effect of each unit individually on the y variable, which is just how much each of the products cost. Okay, and then lastly for this one, let's just calculate total cost for month 16. All right, so all we're going to do here is we're going to use the equation we already have that you should have already set up, this one, and then we'll plug in each of the units we're going to produce for that month, and then just run this in the calculator, right? So this is our total cost equation. Let's start with that. All right, so we want total cost for month 16 using the estimated equation, and so we got to plug in how much of each of the units we're expecting to produce. Okay, so here's month 16. All right, make sure you look at the right month. We're going to produce, or we're expected to produce 450 of unit A. We're expected to produce 660 of units B. And we're expected to produce 540 unit C in month 16. All right. And if you put this in the calculator, this should give you, I got an approximate total cost of $22,000. All right, so 22,552.04. So that's what I got there. And it also, when you get your calculation here, make sure the total cost is somewhere in the right. All right, so we got total cost here of 30,000, 25,000. So it's somewhere in this range. So that looks about right. If you get something like, -5 or 5 million or something that doesn't look right, then it's probably not right. So just double check that it makes sense given the other total costs. So our total cost for month 16 is predicted to be 22,552.04. Okay. All right. Questions on number one? All right. So number two, let's do that one. So this is on the cost regression 3. This one had the binary variable, so similar approach, but a little bit different given the binaries. All right. So part A for number 2 is going to be look at the screen cap for the cost regression 3. And then using data analysis, we estimated this time a multiple regression with total cost is still the dependent variable. And then we have units produced, plants 2 and plant 3 as the 3 independent variables. And so let's write out the equation. Remember that for this one, if you recall that we specified plant 2 and plant 3 only because plant 1 is the case when both of these are 0. So you can't double count here because it'll mess up it won't work. So you have to have one less binary variable than is actually going to be estimated, because when this is 0 and this is 0, then that's plant 1. Okay, so plant 1 is specified indirectly when these two are 0. Okay, so let's write out our equation. Okay, total cost is the intercept, which is 8,867. Okay, plus the coefficient for for units produced, which is 41. All right, plus the coefficient for plant 2, which is 5,187. And then let's go ahead and just do minus, because there's a negative coefficient for plant 3, minus 5,993 times plant 3. All right, so there's our equation, equals total cost equals 8,867 plus 41 times units produced plus 5,187 times plant 2 minus 5,993 times plant 3, right? And then again, when this is 0 and this is 0, then this whole part is 0, and we're defaulted to plant 1. All right, so we indirectly specified plant 1 like that. Okay, part B. Let's interpret the coefficient for units produced, plant 2 and plant 3. Okay, so a little bit different with the plants because those are binary. That's if this, then what happens? Okay, let me set this up here. All right, so the coefficient for units produced is 41. For plant 2, we got 5,187. And for plant 3, we got negative 5,993. Okay, so let's interpret those. So this is the effect of changing, this is the effect of changing this x variable by 1 unit on the y variable, which is total cost. So when we produce one more unit, it costs about $41, right? All right, so producing one additional unit increases sorry, not 21, 41. All right, so producing one additional unit increases total cost by 41. So producing one additional unit costs about $41. All right, and then remember the plants, this is the effect of producing at this plant compared to the other plants, compared to plant 1. So it costs more on average to produce at plant 2 for whatever reason. So that's what this is telling us. So what we can say with this number is all right, so what this means is total cost of plant 2 is roughly the coefficient $5,187 higher. But remember, that's compared to plant 1. So it's this much more than plant 1. Okay, so because these are both in comparison to plant 1, because when this is 0 and plant 3 is 0, that is plant 1. Okay, so this is the additional cost compared to plant 1. All right, or whatever binary variable you did not specify. All right, you can see the total cost of plant 3 is lower than plant 1. Okay, so total cost at plant 3 is roughly $5,993 lower than total cost of plant 1. So plant 2 is more costly than plant 1. Plant 3 is less costly. All right, so that's what those mean in comparison, right? Just how much is total cost more or less compared to the emitted one, which is plant 1. All right, then let's just add this little. Okay, all right, so that's how you interpret those ones. Okay, and then part C, what is the unique intercept for producing at each plant? I'm not sure that we had time to cover this in class, but it's pretty simple because you want to be able to specify the intercept for all the plants, including the one that was not included. So let me just make a little chart and then I'll show you how to get the intercept specifically for each plant because we're working with binary variables, which basically just changes the intercept up or down. All right, so plant one is the easy one because we already have the intercept for that. All right, so remember I said if this is 0 and this is 0, then we're at plant one. So the default intercept, the one that's already specified in the summary output, is the intercept for plant one, 8,867. Okay, so then how do we get the intercept for plant two and plant three? All right, so we already qualified or quantified it in words here. So we said total cost at plant two is roughly this much higher compared to plant one. So let's just add this cost to the intercept for plant one, and that's our intercept for plant two. So it's this much higher. Okay, so all we have to do is for plant two, add the additional cost of 5,187. And we get about 14,054. Okay, and then we're going to do the same concept with plant three, except that one is lower. So let's start with this. And we said the total cost of plant three is this much lower than plant one. This is plant one, so just subtract this from that. Okay, and I got 2,874. Okay, so again, I don't think we did part C. I don't think we did this example in class, but this is what you do. Just start with the plant one. This is going to be the intercept for plant one, whatever you get here in the summary output, and then whatever the coefficient is for plant, sorry, where is this? Down here. Whatever the coefficient is for plant two and plant three, either add or subtract that to the intercept to get the intercept for plant two and plant three. All right, so we see how to do that one. Any questions on problem number two?
Sorry, Professor, could you please go back? Let me see the.
Oh, sure. Yeah,
please?
back up to this one.
Yeah, I just want to ask the question one. Do I have to calculate
Part C?
the question A? Do I have to calculate?
Oh, no, because this one just tells you to get the specific equation. And so this one, you're not actually predicting a total cost. You're just trying to see, the goal here is to see how much the cost was different at different plants. So you see, you're not actually predicting like you did before. So no, for part A, just write out the equation, but you don't have to calculate because we don't have forecasts for units produced plant two or plant three.
Okay, thank you a lot.
You're welcome. Okay, so number three is on the analysis we did for the stock market forecasting project thing. Okay, so a couple questions on moving average and exponential smoothing and using those the hardware sales data that we did in class. So number 3, forecasting the weekly sales, weekly hardware sale at Lee's. All right, so number 1 or part A is look at the screen cap of the hardware sales, and let's use it. So make sure you know how to use specific or the different moving average equations. So using moving average, what is the week 105 sales forecast using an MA2, a moving average of 2, and also get it using a moving average of 3. So specify those 2 different moving averages to get a separate forecast for week 105. All right, so let's start doing this. Okay, first thing you want is a moving average of 2 for week 105. So what all that is, remember, a moving average is the average of the last, a moving average of 2 is the average of the last 2 sales observations. So if you look down here at the screen cap, we're trying to get 105, right? So what happened recently was 103 was 95.15 and 104 was 85.10. So just take the average of those two. That's exactly how you calculate the MA2 for week 105. So 103 was this, 104 was this. Let's take the average of those two. So week 103 was $95.15. All right, week 104 was $85.10. Okay, if you just take the average of those two, you get your MA2 for week 105, which is about $90.13. That sounds about right. Okay, then all you gotta do is get the MA3, which is the average of the last 3. Okay, so that's add the week 102 sales forecast and then take the average of those 3 to get your MA3 for week 105, right? So here we go. Okay, so for week 102, it was $82.90. So for the MA3, we're going to take the average of these 3. So whatever the moving average is, just take the average of the last that number specifies. So MA4 would be average of these 4, MA5 would be average of these 5, and so on. So MA3 is just the average of these last 3. Okay, so let's add the week 102 in there. Which is $82.90. All right, we already know week 103, which is 95.15. And then we know what week 104 is $85.10. All right, so take the average of those 3, so just add them up and divide by 3, and I get for that one I get $87 and 72 cents. So that's how you do the moving averages. Just take the average of whatever the specified number is. Okay. Then B, you're going to do the a couple different simple exponential smoothing calculations. All right. So here's the equation if you need it, which is just telling you to take alpha times the last observation plus 1 minus alpha times the last forecast. All right. So B, refer to the screen cap of the hardware sales. Let's use exponential smoothing. And let's get our sales forecast using an alpha equals 0.8. And then alpha also using is alpha equals 0.9. Okay. So the same equation, but use the different, we're trying different alphas. All right, so for alpha equals 0.8, it's alpha, which is 0.8. All right, then alpha times the last observation, which is the second one is the exponential smoothing one here, the second screen cap. So for week 105, we're using the 104 information to do that. So the last sales data here in the sales was $85.10. So put that in there. Okay, and then if you know what alpha is, all right, you know what 1 minus alpha is. So this is alpha, so that means that 1 minus alpha has to be 1 minus 0.8, which is 0.2. All right, and so for the simple exponential smoothing, multiply 1 minus alpha times the last forecast. So that is for alpha equals 0.8. The week 104 forecast was $93.68. Okay, and I get, if you just put this in your calculator, you're just manually calculating one predictor for exponential smoothing with alpha equals 0.8, and I get about $86, or I get $86.82 for that one. And let's do it one more time with a different alpha, which is 0.9. All right, so you can use the same numbers for, this is still the last 8510 is the last sales data, but you need a different one for this one because it's a different forecasting process. So let's start here. Do it for alpha equals 0.9. So alpha is 0.9. Okay, the last sales observation is, we know what it is, it's $85.10. Okay, 1 minus alpha is different because alpha is 0.9. So if alpha is 0.9, then 1 minus 0.9 is 0.1. Okay, what is the last forecast? What is the week 104 forecast for alpha equals 0.9? Scroll down and look. Here it is, 94.22. Good. And for this one, I get 80. If you put this in your calculator, I get $86.01. Okay, so for that one, yeah, just use the general equation and just pay attention to your alphas, which gives you the 1 minus alpha, and then just look at the last week 104 sales data and then the specific forecast for whatever one you're doing. All right, and then part C, what does the alpha do specifically in an exponential smoothing model? So remember this, changing this or increasing it puts more weight on the very last or the previous observation. All right, so that's it. Increasing alpha puts more weight on the previous observation, and then vice versa if you decrease it. Okay, and then D. What exponential smoothing model would you use? If your historical data had an upward or downward trend, so if you have a trend, and which one would you use if you have a seasonal pattern? So remember, you don't have to calculate this because it takes more advanced software, but you just have to know the types that we used in class. So for the trend, all right, so for the trend, remember we used Holt's method. Okay, and then if we had seasonal pattern, we used Winters's method. Okay, I think in the answer key or the solutions that I posted, you can also put, there's either one of these is fine. Okay, so just list the method. If you have a trend and you want to use exponential smoothing, you could use Holt's method like we did in class. And then if you have a seasonal pattern, right, you can use Winters's method or Holtz-Winters method, same thing. So either of those is fine. Yeah. Okay, so that's number 3. So make sure you can calculate a moving average based on whatever it tells you to specify, and make sure you can calculate an exponential smoothing based on the specified alphas, and just use the general equation. And then part C and part D, I think I've already written the exam, it says the same thing. So you can't get these wrong because this is the answer and this is the answer. So just, the answers for C and D. Don't miss those, they're essentially free points. So just put this, maybe use a different color, put it in purple or something, I don't know, but this is the answer. And this is the answer for C and D. So don't miss those. Those are easy. Okay. Questions on number 3? I mean, specifically parts A and B, how to do that? Good. All right, so we got 2 more questions to do, 4 and 5 based on chapter 10 on the simulations. And then yeah, so we finished up the chapter 10 or the chapter 14 material. And we had a couple of questions from chapter 10 doing the simulation type questions. All right, so everybody doing okay so far? We got a few more questions, then we're done. Okay. All right, so number 4, number 5, it's essentially the same question, but different example. And so this should be familiar because we just did this. The example 10-2 ordering calendars, I think we did it on last Tuesday. So here we go. Simulation with Excel only at Walton's Bookstore. So look at the screen cap for ordering calendars Excel only 1. And so I just want you to know how to calculate one of the simulations so you understand what we did when we repeated it 1,000 times. So just do it for 1. Okay, so part A, question A, what is demand for replication 1 only? Okay, so we set this up, but I want you to understand how the demand is calculated from the random number. So if you look down, I only have one simulation that you got to talk about. So the random number you get here is 0.91. Okay, so what you have to do is just look at the table. This is the lookup table, all right, and report what demand is based on the random number. So if you get a random number of 0.91, what is your demand going to be based on the cumulative probability? So if this is 0.91, what's the lookup table going to tell you demand is? So can you tell what demand is based on a random number of 0.91 by looking at this? All right, so the probabilities are ranged. So this is 30%. There's a 30% chance of this occurring. So that means any random number between 0 and 0.3 is going to give you a demand of 100. Any random number between 0.3 and 0.5, there's a 20% chance of that. That's going to give you 150. Any random number between 0.5 and 0.8, there's a 30% chance for that. So that would give you a demand of 200. And then here's our case. Any random number between 0.8 and 0.91 will give us demand 250. So because 0.91 is between 0.8 and 0.95, the demand is going to be 250. Okay, So do we see how you get the demand based on the random number, right? So whatever random number you get in the example, just look at the table and give the demand with that. So for something in this range, 0.8 to 0.95, which is this, your demand is 250, right? And anything else, your answer is going to be one of these 5 things. Okay. All right, part B is to calculate, just from simulation 1, calculate revenue and ordering costs and refund for replication 1 only. So you know your demand is 250, right? Okay, so let's get revenue first. All right, so revenue is the price of the good, which is the calendars, which is, see, the unit price is the selling price, so it's $15. We sell each of these calendars for $15. Okay, and remember, we have to make sure that we're only selling, or we can only sell the minimum of order quantity and demand. So that means if we order too few, we can only sell what we order. And if demand isn't high enough, then we can only sell what demand is. So the minimum, so basically what's low? 200 or 250. So we see that if demand is 250, but we only order 200, we can always sell the 200 because that's what we ordered. So our revenue is going to be the minimum of the 250 and 200, which is 200. Okay, so revenue is just $15. The price of the calendars times the min of order quantity and demand, which is 200. So revenue is 15 times 200, which is 3,000. Okay, then let's get cost, ordering cost. Okay, so this one's easy because if we order 200 and each unit costs $5, then the ordering cost is just unit cost times order quantity. So it's going to be 200 times 5. Okay, so 200 times 5 is just 1,000. All right, and then finally, let's get refund if there is a refund. So refund could be 0 or it could be something if we order too many calendars. All right, so the refund unit per unit is $1. So if we order too many, we can sell them back at $1 per book. Okay, but did we order too many here? So let's see. Demand is 250. We didn't even meet demand, so we ordered not enough. So we're not going to get any refund because we sold everything we had and we actually needed more. So there's no refund because we sold all these 200 and we actually didn't order enough. Okay, so there's no refund because we sold the whole 200 at the regular price. All right, so if you get revenue and ordering costs and refund, then part C you can get you can get profit, which is revenue minus costs plus any refund if you had one. Okay, so just in general, profit is revenue minus ordering costs plus refund, or revenue minus cost plus refund. Okay, revenue is 3,000. All right, our cost was 1,000. And we didn't get a refund, but I'll just put it in there to be thorough. So there's no refund, but I'll put a 0 in there just so you know if you have a refund, you can just put the number in the equation. All right, so obviously 3,000 minus the 1,000 is 2,000. All right, and then part D, just look at the data table and the clustered column chart for average profit versus order quantity, and which order quantity gives us the highest average profit. So remember, the point of this exercise was to determine if ordering the average of 200 was the best solution, or if you should order something different based on the simulations and the probability distribution. Okay, so if you look down here, all you're doing is pointing out which order quantity gives you the highest profit. So it looks like it's 200, which it is. So it's the highest number here, and confirm it's the highest here. So actually, ordering the average was the best here. So which order quantity gives the highest average profit? It's order quantity 200. All right, so we got one more example like this, but so we didn't. I don't think we did this example in class. So any questions on what we did here? And how do you get? You see how to get demand and how to get revenue, ordering cost, and refund, and then how to get profit based on this example. All right, so questions on what we did on this one? All right, so we got one more, and then. Okay, so number 5 is another simulation one. All right, so number 5, let's do the same type of analysis, but it's going to be a little bit different based on a different random number, right? So make sure you get the random number part, how it correlates with demand, because that leads into the rest of the question. So part A, let's look at the screen cap of this example, and what is demand for this one, okay? All right, so for number 5, our random number is 0.30. So I'll try not to make it exactly on the borders, but technically it goes to the, like, so basically it's if it's less than 0.3, it's 100. If it's 0.3 and less than 0.5, it's 150. If it's bigger than, if it's 0.5 or less than 0.8, it's 200, and so on. So based on the 0.3, what's our random number going to be for demand? So can someone figure out what demand is here? If you get a random number of 0.3? Okay, so we get, well, just look at the table. So if it's, so we got 0.3. And so basically if it's 0.3 and less than 0.5, it's 150. Okay, so we get the random number of 0.3 gives us a demand for this example of 150, right? Okay, then let's just get revenue, ordering cost, and refund for this example. Okay, so there's different numbers, but same concept. So this is the unit cost, which is how much it costs to order the books. This is how much we sell them at, $3, and this is the refund. So revenue is based on the unit price, okay, the selling price, the market price, which is $3. Okay, and then we're going to sell the minimum of order quantity versus demand. So demand is 150, order quantity is 200. So this time is the opposite, where we ordered 200, but we can only sell 150 because that's what demand is. So the minimum of demand and order quantity in this case is 150. So revenue is going to be 3 times 150. All right, which is 450. Okay, what about ordering cost? All right, so this one is just the order quantity times the unit cost. Okay, so it's just 1 times 200, which is 200. All right, then let's see if we get a refund here at 50 cents per extra book, if that's possible. All right, so the unit refund per unit is 50 cents. And we multiply that, if we have extra books we can sell back, if we ordered too many. All right, last time we didn't, but this time we do, right? So demand was 150, we ordered 200. So that means we have an extra 50 that we can get a refund for. So we'd like to sell them at the regular price of $3, but we ordered too many, demand wasn't high enough. And so therefore we can sell, at least make up some of the cost and sell the extra 50 at 50 cents per book, per calendar. So the number of books we get refunded is the difference between order quantity minus demand, which is 50. So we have 50 extra books. we can sell back or get a refund. All right, so 50 cents times 50 gives us a refund of $25. All right, then let's get profit. Remember, profit is just revenue minus ordering cost plus refund, same equation. All right, for these ones, make sure you, like, even if you get demand wrong, just do the rest of the problem, because I'll give you points for doing parts B and C with whatever demand you got. So, I mean, you lose a few points for not getting demand, but if you do the rest of the question correctly with the wrong demand, you'll still get most of the points. So make sure you, even if you don't know 100% what demand is, that you do the rest of the question thoroughly. We know that profit is revenue minus cost plus refund. Okay, so revenue is 450. Cost is 200. And we did get a refund this time of $25. Okay, so that gives us a profit of $275. Okay, then the last part, part D, just refer to the table in the clustered column chart for average profit versus order quantity. And so we're trying to see which order quantity gives us the highest average profit after the simulations. Okay, you didn't do the simulations, but you get the results from them. And so let's check if 200 was the best or not. So if you scroll down to the last screen cap, you see that looks like 250 is the highest, gives us the highest average profit. If you confirm over here. Yeah, so in this case, looking at the chart and the table, you see that 250 has the highest profit after the simulations were run. Okay, and I think that's it for that one. So that's the practice exam, and so we went through the 5 types of questions. So any questions on what we did? Everyone okay to do the take-home final? Okay. All right. Perfect. Okay, so let me close this. All right, so I'll post the video later if you need to see it, but here's the practice exam, and there's a word in the PDF of the same thing, and then my solutions are up there. So what we just did and what we solved should already be there. You can look at that for reference. And let me post your final right now. So give me a second here. All right, so don't want to post the solutions, but all right, so there you go. If you go to Blackboard Final Exam 2020, you should see that I just posted your take-home exam here, just like the two midterms. All right, so just think of this as like another exam. All three exams are worth the same. So here it is. There's a Word document and there's a PDF. That's the same exact thing. You can refer to whichever one is best. All right, so here you go. This is your final exam, your take home, which is due in a week. Same instructions, worth 100 points. If you could prepare your answer sheet as a PDF or a Word document, you don't have to include the questions in the screen. If you want to leave the questions in the screen caps in your answer sheet, that's fine. But all I really need is the answers. So your answer sheet is a PDF or a Word document. And then this is due next Tuesday in a week, week 16. So it just says right here, Tuesday, December 15th, which is next Tuesday, right? Yep. Tuesday finals week. Okay, so do next Tuesday, December 15th, and just email it to me like you do with the exams. And you should see that there's similar questions. One for the multiple regression for cost regression 2, the different types of units, one for the binary variables where you're producing at different plants. Number 3, you got to do the examples of the moving average and the exponential smoothing. And then number 4 is on the simulations one from the ordering calendars. All right, and then you got one more like that. So should be very similar to what we just did. And as long as you understand what we did today as practice, then you should be pretty good to go for the final. All right, so here's your exam. PDF and Word document, you can open whichever one you want, they're the same thing. Okay, that's due in a week via email. Okay, there's all right, so make sure that I've updated your grades up to this one, I think. So you have example 10.2 and the extra credit simulations, which are both due today. So make sure you get those in by the end of today, and I'll update your grades for the examples sometime this week. And yeah, so I think we're almost done. So let me just post the final things. Okay, so make sure if you haven't turned in these two, that you get those in. So the last two in-class exercises are due today. Then the take-home final that you just saw, your take-home final is due next Tuesday. And then assuming everyone submits their work on time and I can get the grades in, I should be able to have your final grades submitted by next Thursday or Friday of finals week. And once everything is finalized, I'll send you guys an email saying this is everything's on Blackboard. So I'll post your final grades on Blackboard. It'll probably take a while for the university to make it official, but you can see your grade probably next Thursday or Friday, and I'll send you an email when I'm done with that. All right, so any questions? And then this Thursday is just office hours. Okay. So we have one more WebEx meeting, which is this Thursday, but we're done with everything. But I'm going to have office hours just in case students have questions on any examples or the final or anything else. So I'll be here Thursday if you need assistance or help. But I think we're just about done with the semester. You got to do your final. But any questions on anything to finish up the semester here?
Professor, so just to be clear, are we meeting on Thursday or no?
Well, so it's office hours. So if I'll be here for the whole class time. So if you have questions or need help with anything, then yes, but it's not required. So if you're done with everything, and then you don't have to. No. And so it's optional, but it's just like office hours. Yeah.
Got it. Thank you.
You're welcome. All right. So I think that's it. Everybody good for finishing up the work and the exercises and the take-home final? Okay, so if you don't have any questions, that's what I got for today, and I guess that finishes up. I'll be here Thursday for office hours, but that's pretty much everything for the course. And so, let me know if you have any questions on anything. But I think that'll do it. And so, thank you all for all your participation during the semester. And I'll email you next week. But thanks for a great semester, and everyone stay safe. And thanks again.
All right. Thank you, Professor.
Thank you.
Thank you, Professor. Bye.
Thank you.